This is the video to start off Unit 6. Unit 6 will be all about the mole. This is video 6.1. So first we've got to talk about what a mole actually is. So we're not actually talking about the animal or anything on your skin or anything like that. The mole in the chemistry is a unit, just like inches, feet, saying something is a dozen, and so forth. So how does a mole relate to chemistry? So just like when you say a dozen eggs, that means 12 eggs. So if you have a mole of eggs, you have 6.02 times 10 to the 23rd eggs. If you have a mole of books, you have 6.02 times 10 to the 23rd books, and so forth. So a mole of anything is that many. So a mole of dollar bills means you would have 6.02 times 10 to the 23rd dollars. So that number is called Avogadro's number. He's the scientist that pretty much did all the calculations and discovered the number. If you write it out of scientific notation, it looks like that. So a mole of helium, so why is this number important? Because when you're looking at atoms and things in a very small level, like atoms and things like that, it's easier to count moles than it is 6.0 times 10 to the 23rd of them. So 1 mole of helium atoms is 6.02 times 10 to the 23rd atoms of helium. But it only takes 22.4 liters of space, which is almost about 2 regular-sized balloons. If you have a mole of $100 bills, you would have 6.02 times 10 to the 23rd $100 bills. And if you stack them one on top of another, that would reach from the sun to Pluto and back 7.5 million times. So when you look at the level of atoms, it doesn't take up that much space. If you blow it up to the size that we can actually see and work with, it takes up a lot of space. Okay? So through this video, we're going to go through several different things. The first thing we're going to talk about is representative particles. Representative particles are F stands for formula units. What's in green is what they represent. So if you have an ionic compound, you are counting how many formula units there are. So if I have 5 NaCl's, you have 5 formula units of NaCl. Ions represent your ions. That one should make sense. Molecules represent your molecular compounds, so your nonmetals. Your diatomics are included in there. So if you're counting oxygen gas, then you're counting the molecules of oxygen gas. Elements are your atoms. You're counting individual atoms. So I want you to take a second, pause the video, and write down what you think these 5 are. Okay? SO3 you should have labeled as a molecule because both S and O are nonmetals, so therefore it is molecular. N2 is your diatomic molecule, so it's a molecule. F3+, anytime you have that charge there, that means it is a ion. NaCl, you have a metal and a nonmetal, which makes it ionic, so you are counting formula units. A single element means that you are counting atoms. So what do particles have to do with moles? So it goes back to that starting thing. 1 mole of anything equals 6.02 times 10 to the 23rd particles. Now you need to pause the video if you do not have a calculator. If you have a calculator handy, you can continue the video. If you do not, you need to pause the video and get one now. A phone works just as well as any other calculator, or you can actually use your computer. Okay? So what we're going to do is think back to Unit 1 when we did conversions. So the same thing here, we're going to take these conversions that we're going to learn today and plug them into the math problems that we're going to go over. So the question's asking how many particles are in 2.49 times 10 to the negative 12 moles of lead. So just like we did back in Unit 1, you are going to start by writing your given. So in this case, we're given 2.49 times 10 to the negative 12th moles of Pb. So you always start by writing your given. So that's our given. Then This should look familiar. We're going to draw a conversion table. Now the same pattern that we used in Unit 1 we're going to use again. We need to get rid of moles. So to get rid of it, we need to divide by it. So whatever unit is here, we are going to put to the bottom. So moles of lead is on top, so we're going to put it to the bottom. Leave space for a number. Okay? Whatever you're trying to get to in this particular step needs to go on top. So what is the question asking? How many particles of lead? Okay, so if we're looking at just lead, which is Pb, what type of particle are we counting? If it's just Pb, that means we were trying to count the number of atoms of Pb. Now, we've only learned one conversion so far, and that is 1 mole equals 6.02 times 10 to the 23rd particles. This is the only conversion we've learned so far. So all you have to do is take this and plug it into that table. So what number is with moles? 1. So we're going to put 1. What's with particles? And atoms is a type of particle, so we're going to put 6.02 times 10 to the 23rd. Then you see that moles of lead cancel, so you're left with atoms of Pb, and that's what we need. So just like in Unit 1, you're going to multiply the top, divide by the bottom. So 2.49 times 10 to the negative 12th times 6.02 times 10 to the 23rd atoms of Pb, and plug it in. And you should get 1.50 times 10 to the 12th atoms of Pb. Now we are doing sig figs again. So whatever your original number, however many numbers it has, that's what your final answer has to have. Okay, let's try another one. Okay, so again, you always start by writing your given. So our given is 5.23 times 10 to the 22nd formula units of NaCl. Okay, and just like the previous problem in Unit 1, whatever unit is here goes to the bottom. So if we have formula units on top, we're going to put formula units on the bottom. And then whatever you're trying to get to goes on top. So what are we trying to get to? It's asking how many moles. So we're going to put moles of NaCl on top. And then using that same conversion that we've learned so far, we're going to plug it in. So what goes with moles in that conversion? 1 mole equals how many formula units? Formula units is a type of particle, so that's where our 6.02 times 10 to the 23rd goes. Formula units cancel. Multiply the top, divide by the bottom. Now this is where you got to be careful of those pesky parentheses. When you plug this in the calculator, you need to make sure you put this number in parentheses, divide, and put 6.02 times 10 to the 23rd in parentheses. If you get an answer that's times 10 to the 40 something, you forgot your parentheses and your answer is wrong. So you should have gotten 0.0869 moles of NaCl. The next part of the video is to talk about molar mass. It's exactly what it says. It's the mass of a mole. So there's a couple steps, 2 steps. First step is to use the periodic table to determine the atomic mass of each element in the compound. Round to 1 decimal place. Remember that the atomic mass is the number at the bottom on the periodic table of each element. Step 2, add together the atomic mass of each element in the compound. So we're going to jump straight to an example here. So just like in the previous unit, you had to be able to write chemical formulas, you still have to be able to do that. So magnesium nitrate, if you were to write it out, you would get MgNO3 2. Again, this 2 is coming from the fact that when you crossed charges. So now the next step to do the molar mass is to break it down into the elements. So our first element is magnesium. If you look on the periodic table, it has a mass of 24.3 grams. Then you're simply going to multiply it by how many magnesiums there are. In this case, there's only one, so it's 24.3 grams. Next, nitrogen. Now you've got to remember that this little guy here goes into the nitrogen and into the oxygen. So you've got to distribute it just like in math class. So if you take the mass of nitrogen, which is 14 grams, we're going to multiply that by 2 because of that subscript. There's 2 nitrogens. So we get a mass of 28 grams. Then we're going to do the same thing for oxygen. The mass of oxygen is 16.0 grams, and the fact that there's a 3 here and a 2 on the outside of the parentheses means that we have 6 oxygens, which gives us 96 grams. So to find the molar mass, you simply add it all up, and you get 148.3 grams. Now, you have to be able to find the molar mass for the next step of what we're going to talk about in the video. So we also need to talk about what a hydrate is. So the word hydrate is simply talking about your water. So if you have CuSO4, this little dot means that it's inside of or a part of 5 waters. So you're going to break it down exactly the same way. So first, you're going to look at just the ionic compound. So you're going to split it up. You're first going to look up the ionic compound of CuSO4, just the mass of that. So copper, it has a mass of 63.5. There's only one of them. Sulfur, 32.1. And there's only one of them. Oxygen has a mass of 16 times 4 because of that subscript. Gives us 64. So then when we find the mass of CuSO4, we simply add it up. So 63.5 plus 32.1 plus 64 gives us 159 grams. So that's step 1. Step 2 is to then find the mass of 5 H2Os. So we're going to find the mass of H2O first. Hydrogen is 1 times 2, which gives us 2. Oxygen is 16, and there's only one of them, so that gives us 18. Now, the fact that there's a 5 here, that means we have to do what with the 18? Take that 5 and multiply it. So 18 times 5 is 90. So then step 3 is to simply take the mass of copper sulfate and add it with the mass of 5 waters. This dot does not mean to multiply. Okay? So you're going to simply do 159.6 plus 90. So that gives you an answer of 249.6 grams. Again, step 1, mass of the ionic compound. Step 2, mass of the water. Step 3, add them all together. Okay, so why do we care about a mass or molar mass? It's because we have another conversion. In the previous video, or in the beginning of this video, we learned that 1 mole is 6.02 times 10 to the 23rd particles. Now you're learning that 1 mole is also equal to the molar mass of a compound. So if I have 1 mole of H2O, I would have 18 grams of H2O. And we're able to use this to go from grams of one thing to moles of the same thing and back and forth. So we're going to do an example. How many moles are in 55.3 grams of calcium hydroxide? So, just like before, we're going to take our given 55.3 grams of calcium hydroxide. So we have to be able to take calcium hydroxide and write the chemical formula. That's going to be extremely important for this unit. So calcium hydroxide, when you write it, CaOH, calcium has a charge of 2, hydroxide has a charge of 1. So you end up with CaOH2. And we're going to draw our conversion table just like we did previously. And follow that same pattern over and over and over again. We have grams here, So we're going to put grams on the bottom. Whatever we're trying to get to in that particular step goes on top. So we're trying to get to moles of CaOH2. And looking back at your conversion factor, what equals what? 1 mole equals the molar mass. So that means we're going to put 1 here, and whenever you have grams, you must find the molar mass. Okay? Now, this is some side work that you have to do. Typically, most students do the side work in this space here because you will never have any number that goes there. So you're going to find the molar mass of CaOH2. This is why it's important that you write the chemical formula correct. So calcium has a mass of 40. .1. O has a mass of 16, and again, it's going to be multiplied by 2. So that gives us 32. Hydrogen is 1, and there's 2 of them, so times 2. To get the molar mass, you simply add it up. So 40.1 plus 32 plus 2, which gives you a molar mass of 74.1. And then you simply take that and put this number into here. So when you look at your conversion table, grams of calcium hydroxide cancel, then we're left with moles, which is what we need. So now you simply multiply the top and divide by the bottom. When you do that, you should get an answer of 0.746 moles of calcium hydroxide. Okay, so next we're going to do one more of these, and in the video we've got one more thing and we'll be done. So how many grams are in 2.50 moles of aluminum oxide? So what are we starting with? We are starting with 2.50 moles of aluminum oxide. So we're going to write the formula for aluminum oxide. Aluminum is Al, oxide is O. Aluminum has a charge of 3, O has a charge of 2. So when you cross, you get Al2O3. And we draw our table. You have moles on top, so we need to put moles on the bottom. Whatever you're trying to get to goes on top. So what are we trying to get to? What's the question asking for? It's asking for grams, so we're going to put grams of Al2O3 on top. Again, we have our conversion factor here, mole and grams. What goes with moles in every conversion factor that we've learned so far, and that is 1. Whenever you have grams, and this is the piece that you're going to have to catch on to quick, whenever you have grams, we need to find molar mass. So do some side work. Al is 27 times 2. Oxygen is 16 times 3. So 27 times 2 is 54. 16 times 3 is 48. So to get the molar mass, you simply add them up. And you should get 102. Then this number is what goes here. Moles cancel. Grams is what we need. So you simply multiply the top, divide by the bottom. So you should get 255 grams of Al2O3. Now, to finish the video, we have one more conversion, and that is that is moles and volume. And this is our last relationship here. 1 mole of any gas is 22.4 liters, and this is at STP. Now, STP, the letters stand for standard temperature and pressure. But not only do you need to know what the letters stand for, you have to know what that means. So a standard temperature is a set temperature that scientists look at. And it's clear in your notes, so look at your notes if you can't see it in the video. So standard temperature is 0 degrees Celsius, or what's called 273 K. So if I say STP, that's the temperature I'm looking at. The standard pressure, which is the pressure that scientists are looking at, is going to be at 1 atm. And this only applies to gases, not solids or liquids. So, we're going to go straight into the examples here. And this is probably the easiest conversion to do if you can simply remember 22.4. So we're going to start with 7.6 moles of argon. And we're going to follow that same pattern. We have moles on top. We need to get rid of them, so we're going to put them on the bottom. Whatever you're trying to get to goes on top. So what is the volume? Now, whenever we're dealing with volume in this class, for the most part, we're going to be looking at the unit liters. So we're going to put liters of AR on top. So our conversion factor is the fact that there's 1 mole for every 22.4 liters. Moles of AR cancel, and we're left with liters, which is what we need. So you multiply the top, divide by the bottom. And you should get 170 liters of argon. Okay, so our last example, same sort of setup here, but this time we're starting off with 432 liters of N2. So the same thing, whatever's here goes to the bottom because we're trying to get rid of it. Whatever you're trying to get to goes on top, so we're trying to get to moles of N2, so that goes on top. Looking at the conversion factors that we've learned, 1 mole equals 22.4 liters. Liters cancel. Moles is what we need. Multiply the top, divide by the bottom. And you should get 19.3 moles of N2. Now we will be doing a lot more practice in class. This is going to be one of those things that you have to practice, because if you don't, you most likely will not understand it.